All right, we are recording. So, lesson 33, and feel free to jump in if you have questions while I'm doing this. First, we are going to review conversions. Everybody did much better on the makeup work, but it still wasn't 100%. And so, example 1, we're just going to go back over some things, and maybe if you see it again, exactly what I want written out, then you will do that. So, changing 216 inches squared to feet squared. We put it over 1, and then we multiply by the unit multiplier. If I want to just do it one at a time, I could say that there's 12 inches in 1 foot, but that only crosses out one of these, so I need to do it one more time. That way, I know that I'm crossing out 2 inches on the bottom and 2 inches on the top, so I will have feet squared when I'm done. And that reminds me that I'm dividing 216 by 12 twice. So hopefully when we do that, okay, so 216 divided by 12 once is 18, and that little right here, and then 8, well, I guess I should put it up here. 18 divided by 12 will be 1.5. So 1.5, and then my units are feet squared because I have 2 of them. So make sure you write this out. Make sure your answer looks like this with your units in it correctly. And know that these will be on all the tests from here on out. So that's only like 2, but we're going to just review it every test because this is probably one of the most important lessons as you use it again in science, and then, you know, throughout your life if you ever want to convert anything, which I know you guys all will. So, all right, example 2, 48 kilograms is how many pounds? So if you put it over 1 and then multiply, I want kilograms on the bottom, which means I want to use the one where it's 1 kilogram to so many pounds. And if I look on the conversion chart, it's 2.2 pounds. So now we're multiplying 48 times 2.2. The kilograms will cancel out and we'll be left with pounds. So 48 times 2.2 is 105.6 pounds. Now, I do want you guys to also think about like a common sense check at the end. Is kilograms more than pounds, or is pounds more than kilograms? Well, kilograms are heavier, so when we convert, the number of kilograms should be less than the number of pounds. So that's correct. We've done it the right way. If you're converting inches to centimeters and you say there's 10 inches, and then when you do the conversion, you end up with 4 centimeters, is that going to be correct? Common sense tells you inches are bigger than centimeters. So you should have more centimeters in your compared to your inches measurement. So when you do this conversion and you get this, you should just double check common sense. Does that make sense? And it doesn't. So you probably switched your fraction on your unit conversion. So definitely be looking at it and making some common sense judgments here at the end. All right, did everybody do okay with lesson 32? I haven't graded what I have right now.
I think I did.
I don't remember, and I turned it in yesterday. I think so.
Okay, well, I can review it if we need it, but I think you guys are probably good, hopefully. But, you know, that's what you said on unit conversions too, so, you know, just saying. Okay, well, I won't do any of lesson 32. If you do have questions, you can always email me, and I will grade them before tomorrow night. And so then we'll also have a help session tomorrow night, and I'll go over any that we missed if that was a problem. That way, hopefully, we can complete before you take the test. Okay, so lesson 33 is on bases other than 10. And I know that might seem really confusing, but I think this is a really fun lesson, and it will help you in some of your critical thinking skills. It really actually helps you to understand place value better. I know you thought you learned that in kindergarten, but this will really help you understand it. So in our decimal system, we use base 10. That means that each place value is 10 times the previous spot. So we can think of it like this. If we have the number 378, this is in the 10 to the 0 spot. Remember that any number to an exponent of 0 is going to be 1. So it's like the same thing as saying it's the 1 spot, which it is. And this spot is 10 to the 1. 10 to the 1 is really the 10 spot. And then this one is 10 squared. 10 squared is 100, so it's the 100 spot. If we kept going, this would be 10 to the cube, which would be the 1,000 spot, and so on. So, but there are other bases that you could write numbers in. I think everybody's probably heard of binary, which they only use ones and zeros. So in binary, it's base 2. And so if you had binary, this would be 2 to the 0, this would be 2 to the 1, 2 to the 2, 2 to the 3. So if my number was 1001, what would that really be? Well, that means that in this spot, this is like the 1 spot, there's 1. This is no longer the 10 spot, it's actually the 2 spot. So any number here, you'd multiply by 2 to add up. Any number here would be 2 squared, or the 4 spot. And this number would be 2 to the cube, which would be 8. So this is like the 8 spot. So instead of 1,110 and 1, we have like 8, 4, 2, and 1. And I know it's kind of confusing, but we'll go through some examples on how we really convert this to our base 10. But just know that there are other bases. So binary is base 2. Some of the other ones that we'll use more often in the homework would be like base 4, base 8, or base 12. So in base 2, we can only have 2 different digits. We either have 0 or 1. In base 10, we have 10 digits, but think about it. Remember that we start at 0, which counts as a digit, and so we go to 9. So it's really like one number before the end. So in base 4, we would use the digits 0, 1, 2, or 3. You won't have a 4 in base 4. In base 12, you'll use 0, 1, 2, all the way to 9. And then for the number 11 and for the number 12, you'd really, for the numbers 10 and 11. This is where I get confused. Okay, so for the numbers 10 and 11, you will use an A and a B. And then once you get to 12, you would use the next place value spot. So in base 12, you're going to see digits from 0 all the way to B. If you were ever to go to base 16, you would see from 0, 1, 2, all the way to 9, and then you would see A, B, C, D, E, and F. So you'd go all the way to F. So remember, in the base, you're going to use the digits up to that number. So in base 4, we use up to, we don't count the 4. In base 8, we would go from 0 to 7. But then if we have bases bigger than 10, we'll use the letters in the alphabet for the next ones. Because there's no way to write a 10 in one place value spot. We just don't have the digits for that. Does that make sense?
Mm-hmm.
Kind of?
Yes.
Kind of, sort of, but not really.
Okay, well, let's do some examples and hopefully we'll get a little bit better. Okay. So on the second page of your notes, if we have written out numbers before, we write them out. We can write them out in exponential form. Oh, one thing I missed. We use the subscript to denote like what base we're using. So in these lessons, you might see a number like this within the subscript 10. So this subscript, written really small, tells us what base we're in. So if we have 274 in base 10, that's the normal 274 that we think about, we could write it out in exponential form and say that it's 4 times 1 plus 7 times 10 plus 2 times 100. And if we were to do that in exponential form, we could say 4 times 10 to the 0, because that's the same as 1, 7 times 10 to the 1, and 2 times 10 squared. See, those are the same. That's just telling us our place value spots. And then, you know, when you multiply 4 times 1, you get 4. If you add that to 70 and 200, then you get 274. So now we can do the same thing even if the base isn't 10. So this is example 4. So let's say we have 357 in base 4. I'm going to do it the same way I did these here. I like to start with this one. I believe your book teaches you to start the other way. It really doesn't matter because we're adding. It doesn't matter which way you start. But I like to start here. So 7 times, 4 to the 0. Plus 5 is in the next spot. So 5 times 4 to the first power. Plus my last one is 3 times 4 to the second power. So now I have to figure out, I'm going to take an extra step and write out what that 4 to the first power and the second power look like. So here it would be 7 times 4 to the 0 power is 1. 5 times 4 to the first power is just 5 times 4. And then here we have 3 times 4 squared is 16. So 3 times 16. Now I'm going to actually multiply these together. So I have 7 plus 20 plus 48. And then the last step is to add these all together. So 48 plus 20 is 68, plus 7 more equals 75. And this now I have converted to base 10. So what is 357 from base 4 in base 10? It's just the number 75. So do we follow that a little bit?
No.
I followed number like the 27 4 to 274 to the 10th or whatever else. Yeah, I got that.
Okay, so let me just kind of walk through this a little bit and then we'll do another example. So here I'm taking every spot and marking it like this is my ones, this is my tens, this is my hundreds.
Yeah.
Except that I'm doing it now with like base 10 and exponents. So 1 is the same thing as 10 to the 0, 10 is 10 to the first power, and then 100 is 10 to the second power.
Yeah, I understand that. It's the other.
Well, so then I can take it down here. Now we're in base 4. So this spot is 4 to the 0, this spot is 4 to the first power, and this spot is 4 to the second power. Now I'm just taking this, multiplying it, and then adding it to the next one. So I'm expanding it, making it bigger. So, but this way converts it into base 10.
I'm just curious, who made that? Like, what was it used for? What is
Well,
it used for?
So it's very, very useful in computers because of binary. So binary code, there's only 2 possibilities, right? It's either 0 or it's 1. So they can code things because they can have a little switch. The switch is either off or it's on. So maybe you have 8 switches in a row, off and on combinations, and that can convert into numbers or numbers in base 10 that we'd be used to, or letters even. So there's a whole binary alphabet that's like, I want to say it's 8 digits, even though you really only need 6 of them, but the first 2 are zeros. Anyway, well, probably because of the digits. Yeah, probably it's a combination of digits, like numbers and letters. But anyway, so the binary alphabet is like 8 spots that you have to code that are either open or closed. They're either 0 or 1. And so every 8 spots gives a letter or a number. And that's how like the insides of your computer work. They're just so super tiny that now they fit in like cell phones and watches but it's all based on, you know, those open and closed switches.
Yeah.
Anyway, so binary
So
is important. Why do
you?
you have base 4 and base 12? I don't know. Maybe I will share on Google Classroom some reasons you would do that after I look them up. But I think it's good because I think it really helps you understand place value. I also think that it's kind of a fun problem solving. you know, every time you stretch your brain, you can think better the next time over something different. You know, you can do yoga stretches even if you want to go running because it helps your body to be stretched and ready to run. So there's my definition of why we should do all the math problems I give you. Because it stretches your brain.
Makes my brain hurt.
My kids are still crying out there. I really hope you can't hear that. Though I've heard students tell me that they can hear the ducks when they're right outside the window. Anyway,
Ducks?
right now it's screaming children. Okay, this one is in base. We're just going to ignore them. This is base 12. So if you want to, writing out kind of like the place value, this is 12 to the 0. This is 12 to the first power, 12 to the second power, and 12 to the third power, which gets to be a really big number. All right, so as we start to convert it, remember that B is just, A comes after 9, so we have 9AB. So A must be 10 and B must be 11. So it's going to be 11 times 12 to the 0. And then I'll add 7 times 12 to the first power. And then A was 10, so 10 times 12 to the second power. And then 4 times 12 to the third power. Now I'm just going to do my exponents. So 11 times 1, 7 times 12, 10 times 144, and 4 times 1728.
Now, did you have that memorized?
No. But I was prepared enough to write the answers on my notes. So there you go. All right, so then we have 11 plus 84 plus 1,440 plus 6912. Now you just add these all together. The total is 8,447, and you may want to denote that that's in base 10, and that's the same as this number in base 12. Okay, how was that one? A little better?
So it will it does it can there so far the problems when you convert it back to base 10, it's not always the same amount of digits. It's been less. Is it always going to be like the same or less?
No, if I had a bigger number in base 12, see this number actually went up. Remember base 12, it was a 4 right here, but 12 is bigger than 10. So this number will look bigger in base 10. So if you're going from a bigger base to a smaller base, the number will look bigger. In the one above that we did, we went from a small base to a bigger base, base 10, and so the number looks smaller.
Yeah.
So it should just be the opposite of the base. So the base went up, so the number gets smaller. This base from 12 to 10 was a lower base, so the number itself got bigger.
Yeah.
If this had been like a 6 or a 7 in base 12, we probably would have been over another place value, so it would have been more digits. Interesting question. Okay, anything else on these? You're just nodding along saying, hopefully I'll figure it out.
Exactly.
All right, hold on, I'm going to save it.
Ooh, answers.
And you should open the answers page.
Yeah, please.
I don't think there would be anything. I haven't written your test, so it's not like I can give you the answer test.
Never mind.
Uh-oh, what happened to my shared screen? Is it still there?
I can see like a white page.
Yeah.
Well, it disappeared though on me.
Yeah, now it went away.
Yeah, we see your.
Yeah,
Okay.
now I see your umbrellas.
My
Yeah.
umbrellas. Well, usually there's a green thing around here, but it's not showing me that. Okay, so are you back to seeing the white page?
Yes.
Yes,
Yes.
ma'am.
Okay, well, it's there. It's just not showing it to me. All right, example 6. What is this number in base 10? Didn't we just do that?
No, ma'am.
We did number 5. Or example 5.
Oh, this is just one more example of the same thing. I thought we were doing it the other way, but not yet. Okay, sorry.
You're good.
All right, so this number in base 8. So again, we're gonna write like 8 to the 0, 8 to the 1, 8 squared. So 6 times 8 to the 0 plus 7 times 8 to the first power plus 3 times 8 squared. Now we work our exponents, so 6 times 1 plus 7 times 8 plus 3 times 64. And then 6 times 1 is 6, 7 times 8 is 56, 3 times 64 is 192. Add these all up, and I think it's 254, and that's in base 10. All right, pretty good?
Yeah.
All right, so now we're gonna go the other way. Now we go the other way. All right, we have 62 in base 10. What is it in base 4? Yeah, so now we get to go the other way. Okay, so what you're really asking is I need to make it into base 4. So instead of base 10 of 10 to the 0 and 10 to the 1, I'm going to have 4 to the 0, 4 to the 1, 4 squared, and 4 cubed. So I'm just going to write these out below it. So 1, 4, 16, or 64. So if I were to put a digit of 1 in this spot, that would mean I would have at least 64. Is there 64 in this number to take out?
No.
No.
No, good, because it's only 62. And your notes say so if you're following along. So then we're going to move to this next place value. How many 16s can come out of 62? So I'm going to take 62 and I'm going to divide by 16. And then I'm going to check. It's 3. So 3 times 16 is 48, right, guys? I don't have this written down. I think so.
That's what you said earlier.
That's okay, well, good. All right, so then 62 minus 48 is going to be 12 and 5. Okay, so 12 minus 8 is 4. 5 minus 4 is 1. So I have 3, remainder 14. So that means 3 16s came out of this number. So in the 16 spot, I can put a 3. But I have 14 remaining. So in this spot, I take them out in groups of 4. How many groups of 4 can I get out of 14? Hopefully we could actually do this one in our head.
3.
We know that 3, good. So 3 times 4 is 12, and we will have 2 remaining. So we can put a 3 here because we can take out 3 times 4, or 12, and we'll be left with 2. And so this is our 1 spot. So how many 1s can we get out of 2? We can get 2 groups of 1 each. All right, so the last one is always just your last remainder. But do you see how we're just taking out each place value, however many times we can without going over, and then the remainder gets bumped down to the next place value. How many can we take out? And then it gets bumped down to the next one. Okay, so it's kind of reverse of what we just did. Now we have, so our answer is 332 in base 4. If we wanted to go backwards and check, we would take this just like we'd been doing. So this is our 4 to the 0 spot. So we'd have 2 times 4 to the 0 plus 3 times 4 to the first power plus 3 times 4 squared. and we would double check that. 2 times 1 is 2. 3 times 4 is 12. And then this is 16. So 3 times 16 is 48. You would add that together. 48 plus 12 is 60, plus 2 more is 62 in base 10. So we went that way. We divided when we want to change into a different base, and then we add and multiply when we want to go back to base 10. Too confusing?
No, I mean a little.
I'll
It's just
figure
trying
out
to
when I
get the
try it on
basic
my
thing.
own.
All right, so we will try number 8 and see what happens. All right, so 8, 9, 4, 2 in base 10 change to base 12. Okay, so if we were just to write out what it would be, so base 12, okay, hold on, we're going to end our class in 10 minutes, but we should be done. Okay, so 12 to the 0 power, 12 to the first power, 12 to the second power, 12 to the third power. And remember, 12 to the third power was 1728, 12 squared, 144, 12, and 1. So do we need to do a 12 to the fourth power? I don't think so. 12 to the third power is 1728. There will be some of those in here. So we're going to start with that place value. So 8,942, and we're going to divide by 1728 and see how many 1728s we can pull out of 8942. All right, your good guessing skills come in. Luckily, I've done this one. So it's 5. 5 times 1728 is going to be, 5 times 8 is 40, 5 times 2 is 10, plus 4 more. 5 times 7 is 35, 36. 5 times 1 is 5, plus 3 is 8. So subtract that, and we get 302. No, 602. What? Did I do this wrong? 5 times 7 is 35, 36. Oh dear. Okay. Well, now I'll be doing it for real since I did it wrong before. Anybody want to shout out? Did I do it wrong here, or is this correct now?
Is it calculator?
I think we're good now. I think I did it
Yeah.
wrong.
I think it's like 5.17 something.
I think you did it right though.
That looks right. Okay, before I had 600, but I don't think that's it. Okay, so it's remainder 302. So this 5 goes in the 1728 place value spot. So we'll put a 5 right here. So now I do 302, and I'll be dividing by the next place value spot of 144. So this goes in twice. 2 times 144 is 288. I subtract it. Let's see, we'll make this 29 and 12. So 12 minus 8 is 4. 9 minus 8 is 1. And there's a 0 here. So this 2 goes in the 144 spot. I have a remainder of 14. So if I have 14, I'm taking 12 out. That only happens once. So I have a 1 in the 12 spot, and then I have 2 1s left. So 2 goes in the 1 spot. So our final answer would be 5212, and that was in base 12. Is that good? Anybody want to correct me? No. Okay, so a couple things. what if we had gotten here, and when we divided 144, let's say that it had only been 289. So when I did this, I would have gotten remainder 1. I then am at the 12 spot. If I have only 1, can I take 12 out of it?
Mm-mm.
No. So then I would have a 0 here with 1 still remaining to put in the 1 spot. So don't get tripped up in case you have to skip a spot. If you skip a spot, just put a 0 in there. All right. That's it for today's lesson. Go ahead and give it a try between today and tomorrow night. And then tomorrow night, I will be back on Zoom so you can come and ask me more questions.
Yes, ma'am.
Is that good?
Alright, yes, sir.
Mm-hmm.
As good as it's gonna get right now.
All right. Well, that's good.